Good morning to all.
Morning, sir.
Very good morning. Very good
Good
morning.
morning, sir.
Very good morning. Shall we start now?
Yes, sir.
Okay. So, from now, the remaining classes, I am going to discuss about some of the important chapters which are most frequently appear in the examination question paper, especially the problem-oriented areas. From unit number 3 and 4. I hope you know very well that your syllabus is bifurcated into two parts. One is theory 60%, practical 40%. These practical questions will appear from unit number 3 and 4. Unit number 1, 2, and 5 are theoretical oriented. I have covered 1 and 2. Now I am going to take up 3 and 4 together. And in the order of importance from the examination point of view, some topics I am going to discuss with you. One among them is chi-square test from unit number 3. I think now it is visible on the screen.
Yes, sir. It's visible.
Yes. Okay.
Yes, sir.
What is this chi-square test? It is test of describing the magnitude of the discrepancy between theory and observation. Rather to say, when there is a difference between theoretical concept and actual observation, actual performance, we use to test whether such difference is a significant difference or not. When there is a difference between theoretical concept and actual observation, we are going to test whether the difference is significant or not. That is the simple meaning of chi-square test. Now this test has been defined as like this. These are the assumptions of this test. Only when these assumptions hold good, you can apply this test. Now, why I am putting all these assumptions here is before taking the problem. Sometimes in a theory question, you may be asked to write about the assumptions of chi-square test also. That is the reason why I am putting on the screen now. Data must be categorical. Number two, the observations must be independent. The sample size must be large enough with expected frequencies of at least 5 for each category. So minimum 5 data should be there at least. Categories must be mutually exclusive. The data should be collected randomly, that is random sampling method is to be adopted. Data should be in the form of counts or frequencies, that is it is measurable in the form of numbers. And the sample size should be large enough. And for putting this chi-square test, ensure sufficient expected frequency in each cell. So these are the assumptions with which this particular test goes. Say then uses of the chi-square test. The first use is goodness of fit test, which means to determine if a particular sample data matches with an expected distribution. This test is being used. Say for example, if at all you want to test whether a die is a fair one or not. You know, die is having 6 faces. No? Whether to test the die is fair one or not, you can use chi-square test. See, the expected frequency of each face is 1, 2, 3, 4, 5, or 6 because it has 6 faces. When you toss a die, what do you expect? You may expect to turn up either 1 or 2 or 3 or 4 or 5 or 6. This expectation should be equal if the die is fair. The die is fair, the occurrence of 1, 2, 3, 4, 5, 6, all these sixes occurrences are having equal chance. If not, if the die is not fair, that is suppose that on one side it is having more weight than the other sides, then naturally when you toss the die, the side which is having the weight, more weight will go down, and the side which is having less weight will come up. So in that case, you can expect what will happen when you toss a die. So that expectancy is there. Already, if you can expect what will happen, then it is not a fair one. Therefore, to test whether die is fair or not, this chi-square test is being used. This test is used when you have a single categorical variable and want to see if the observed distribution fits an expected distribution. So, whenever you have only one particular variable, there is nothing to compare with that. Then in that case, you can use this test and see whether the observed distribution fits into expected distribution or not. This is one of the uses of the chi-square test. The second use is test for independence. Here the purpose is to verify if two categorical variables are independent or associated with each other. Say, for example, when you want to examine if there is an association between gender, that is male and female, regarding voting preference, particular party A, party B, or party C in an election survey, then you can use this chi-square test. Then the third use is testing homogeneity of the proportions. That means to compare the distribution of categorical data across different populations or groups, one can use chi-square test. So, for example, when you want to verify if the preference for a certain type of a fruit is the same across three age groups, that is children, adults, and seniors, then in such case you can use the chi-square test. So these are the important uses of chi-square test. Now let us move on to the practical part of it. Now I request all of you to take your study material and turn to page number 119. If at all, if you have study material with you, you take that study material, turn to page number 119. Ready?
Yes, sir.
Now the formula for chi-square test. Chi-square symbol is chi-square, x square, that is written as chi-square, CHISQUAR. The formula is chi-square is equal to sigma O minus E the whole square divided by E. And you can see the formula in page number, I will tell you the page number. Just a minute. Go to page number 114, the formula is given there. In your study material, if you turn to page number 114, you can see the formula. Sigma O minus E the whole square divided by E, where O is the observed frequency and E is the expected frequency. So again, I repeat that when there is a difference between observed frequency and expected frequency, to test whether the difference is significant or not, chi-square test is being used. The formula here is sigma O minus E the whole square by E. Right? Now let us move on to the problem given in page number 119. Will I read the problem now? 119, page number 119. You can go through the problem so that understand the data given in that. I will explain the problem and then I will tell you how to work out this problem. Just 2 minutes I will give a time. Just go through the problem and note the contents of the problem. It runs from 119 to 120. Some disturbance is there. One Shagana Parveen, please. Thank you. Now go through the problem, please, quickly. For those who do not have the study material, you can see the screen, please. On the screen, it is displayed also. So here, a medical campaign is being conducted. That is anti-diabetes campaign is being conducted in a particular area where a medicine, say X, name of the medicine is X, was administered to 812 persons out of a total population of 3,248. So total population of that particular area or village is 3,248. Out of them, only 812 persons were administered this medicine X, that is treatment is given to say regarding antibiotics. Now, the number of diabetes cases is given in the table. When you go through the table, you can see medicine X is administered on 812 persons in total. On the remaining 2,436 persons, no medicine was administered. Are you able to understand the concept now? I repeat, medicine X was administered on 812 persons, whereas on the remaining 2,436 people, no medicine was administered. Right. So the purpose here, what is the purpose of administering the medicine? When the medicine is administered, they should not be contacted with that particular disease. That is the purpose of administering the medicine. Right? Do you agree with me? When a particular medicine is administered, what is expected is those persons who have been administered with the particular medicine should not be contacted with that particular disease. That is the expectation. Now, actually, what happened that we have to see here. Say, medicine was administered on 812 persons. Out of them, only 792 were found without diabetes. That is, diabetes has not attacked them. But in spite of administering the medicine, 20 people got diabetes. That is the observation, actual observation. What is expected? If you administer medicine on 812, all those 812 should not be affected by diabetes. That is the expectation. Whereas what is actually observed is, out of them, only 792 were not affected by diabetes, whereas 20 were affected by the diabetes. Now, another expectation. When you don't administer the medicine, what will happen? They will be affected by the disease. There are two things you have to remember. When you administer the medicine, what is expected is they should not be affected by the disease. When you don't administer the medicine, they should be affected by the disease. Now, what happened when no medicine was administered on 2,436 people? What is actually expected? They should be affected by the diabetes. No. What happened? Out of them, 2,216 were not affected by the diabetes. Only 220 were affected by the diabetes out of 2,436. Now, the total number of people affected by diabetes out of 3,248 is 240 only. And the remaining 3,008 were not affected by the diabetes. Now, the question is whether really medicine X is useful in checking the diabetes. This is what we have to check now. discuss the usefulness of medicine X in checking diabetes. Do you understand the problem now?
In textbook checking malaria.
That is printing mistake, ma. You just make it a correction. Make a correction there, because the problem started with diabetes. When you administer medicine for diabetes, it could not check malaria, no. So that is a printing mistake. You change it as diabetes. So I think you got the concept of the problem now. Shall I move on to the solution part of it now?
Yes, sir.
Yes.
Yes, sir.
Okay. So you can go through the solution also. I will explain that now. Okay. Now, what is given in the problem, that is 2792. If you see the screen, I have just marked its total column in red color. Right? That means total should not be taken into consideration for further analysis. That is what meaning of it. Total should not be considered for further analysis. Okay? Only these four variables, 2792, 220, 2216 are to be taken into consideration. So these four values are called observed frequency. That is actual one, observed frequency. For this observed frequency, we have to calculate the expected frequencies. Then chi-square test is to be administered, because the variables required for chi-square test are two. One is observed frequency, other one is expected frequency. Here in this problem, observed frequency is given. We have to calculate expected frequency. How to calculate expected frequency, I will tell you now. Let us take the first cell, that is cell number 11. What is the input given in that cell number 11? What is the value given?
20.
20. For this 20, we have to find out the expected frequency. Right? How to find out expected frequency means you take the total of the particular column, and that is multiplied with the total of the particular row in which the value is to be found out. So take the total of particular column. That is, what is the total of that particular column? 240.
240.
That is multiplied with total of the particular row, that is 812. So this product is to be divided by the grand total, that is 3248. I will show the formula so that you can understand this. So this is how it should be done. Is it clear on the screen now?
Yes, sir.
Yes,
it is
sir.
clear.
Yes, sir. Yes, sir.
So to find out the value for the first cell, 11, take the total of the column, multiplied it with the total of the row, divided by grand total. You will get the value, expected frequency as 60. Right? Like that, for every cell, we have to find out the values. For every cell, we have to find out the values. I will show you how it is being done. You can find out the value for second one, that is 1, 2. You can find out and tell me what is the value for 1, 2. First row, second column.
225, 2256, sir.
2256. Okay. Like that, you find out the value for each and every cell. So now you can see the values of expected frequency on the screen. Total remains the same. Total should not be changed. The values inside the cells should be changed. So that you get 60, 752, 180, 2256. Like that you get the answer for this. So do you understand this now? Let me move on to the next part of this. You can go through the study material also. It is given in the study material clearly. 60, 752, 180, 2256, right?
Sir, can you please tell how 752 has come?
Which one, ma?
752.
752. Okay.
And same
What
as
is-
180 also, sir.
Yeah, I will tell you. 752. What is the total of that column?
3008, sir.
3008 multiplied by total of that row. How much?
2436.
No, 812.
812. 812.
So 3008 multiplied by 812 entirely divided by the grand total 3248.
Sir, is it a kind of a like matrix related calculation?
Yeah, sir.
Okay.
Yeah. Those who understand the matrix can easily do it. Otherwise, it is simple process. So otherwise, I will tell you one thing. First value you have calculated, no? And let me go back to the screen now. Okay. First value you got 60, no? Correct? See this? How we got the first value?
Yes, sir. Yes, sir.
60. Now listen. Now if you see the
Minus it from 812, sir.
which one, ma?
60 minus 812.
Yeah.
752.
That's what I want to tell you. So when you calculate the first value, other values you can easily find out by subtracting the totals. See, if you take the total of this row, it is 812. 60 is the first value. Balance should be the second value, 752. Similarly, when you go back to the first column, first value 60, the total of the column 240, balance is 180. So coming by row, second row, 180 is the first value. So total is 2436. That the balance is the value for the second cell. That is 2256. Like that also you can calculate. If it is 3 by 3 matrix only, you have to find out 2 more values. Right?
Okay, sir.
Okay.
Okay, sir.
Now the solution. So 4 columns are there. You can see in your study material also. First column observed frequency O, second column E, then O minus E the whole square, and O minus the whole square by E. So this O observed frequency is written from the problem. Expected frequency is written from your calculation. Then you find out the difference between these two and square it up. Then that value is to be divided by E, expected frequency. You will get value for every row separately and find out the total of this last column. Just try this. When you enter this observed frequency and expected frequency, you should follow the same order. You should not change the order. If you go row wise, you do it row wise for the expected frequency also. If you go column wise, you do column wise for expected frequency also. It is left to your discretion. You can go row wise also or column wise also. I have entered the observed frequency row wise. First row 20 and column wise. First column 20 and 220. Second column 792 and 2216. Same order is to be followed for entering the expected frequency also. Otherwise, values will get changed. Then the difference is minus 40, plus 40, minus 40. So plus 40 like that. So this 40 square is 1006, whether it is minus or plus, square it up 1600. So this 1600 first row is divided by the corresponding expected frequency 60. 1600 by 60, you will get 26.667. Like that for all the values we have entered. And find out the total of that also. From the study material also you can find out that. Shall I move further now?
Sir.
Okay. So next step is to make a conclusion on this. So the chi-square value is 38.593, right? Now we have to refer to the chi-square table to find out the table value, and based on the table value only we can make a conclusion. The table value will be always given in the examination question paper itself. If at all it is not given, let me explain you how this value is to be found out from the table. Before that, let me conclude this problem and go back to the table now. Now listen. We have to find out degrees of freedom. I think it is clear on the screen now, solution. Or you can
Yes, sir.
take your study material itself. There itself I can explain you. So we have to find out the degrees of freedom to find the value in the particular table. Degrees of freedom here is row minus 1 into column minus 1. How many rows are there in this problem? How many rows are there in the
Two.
given problem? 2 rows only. Leave the total columns. Leave the total columns and total rows. So 2 rows and 2 columns. Right? So 2 minus 1 into 2 minus 1, you will get 1. In page number 121, in the beginning itself it is there. You can see that. Page number 121. V means degrees of freedom is equal to R minus 1. R minus 1 means row minus 1. C minus 1 means column minus 1. So 2 minus 1 into 2 minus 1, you will get 1. So degrees of freedom 1, and level of significance is also to be fixed. What is this level of significance? To put it in simple words, to what extent you can trust this, testing process. Say it can be about 95% or 99%. Some mistakes may arise in sampling. That is called sampling error. Therefore, we are giving leverage for the sampling error. So to the extent of 95% or 99%, we are confident that our testing procedure will be correct. So that level is to be chosen. So in this problem, they have chosen 5% level. That is why it is called chi-square 0.05 is given. So for 1 degrees of freedom at 5% level of significance, the table value is 3.84. I will tell you how this table value should be located from the table later on. Now let us conclude this and come to the end of this problem. Then I will go back to the table now. So table value will be given in the problem. Don't worry, that will be given in the problem. If at all it is not given, I will tell you how to locate this. Okay. So this 3.84 is the table value. Now the conclusion is to be made. What is given in the conclusion? See, the calculated value of chi-square is greater than the table value. Is it correct? Table value is 3.84. What is the calculated value? How much is it?
38.593.
Yeah, exactly. 38.593. So that calculated value is more than the table value. If it is the case, the hypothesis is rejected. What is hypothesis? What is the question given in the problem? I will go back to the question. You go back to page number 120. See what is being tested, what is being asked now. Discuss the usefulness of medicine X in checking the diabetics, right? Whether it is useful in checking the diabetes. So the null hypothesis is, we say that medicine X is not useful in checking the diabetes. That is how we have to start. That is called null hypothesis. When they ask is it useful, we start with the assumption that it is not useful. That is called null hypothesis. Now, by concluding that what we say in the page number 121, the hypothesis is rejected. What is hypothesis? Medicine X is not useful. That is rejected. That means what is the meaning of it?
Medicine yields the benefit.
Is wrong.
Yes, that is what concluded here finally.
Sir, how we are getting 3.84 value chi-square 0.05?
Yeah, that I will tell you. That will be given in the question paper itself.
Okay.
If not, I will tell you how to find out this. Just a minute.
Okay.
I will take the table also.
Sir,
Let you know. 1 minute.
sir, I can't understand the last part, sir.
I will explain. Wait. So the table value is 3. I will explain this first and go back to the table. The table value is 3.84. Don't worry, that will be given in the problem itself. If not, I will tell you how to find out after completing this. The table value 3.84. What is your calculated value?
38.5.
Note down carefully in your notebook. Whenever the calculated value is more than the table value, the null hypothesis is rejected. Note down, please. Note down. Whenever the calculated value is more than the table value, null hypothesis is rejected.
Sir, once again repeat, sir.
When the calculated value is more than the table value, the null hypothesis is rejected. The null hypothesis. Other one, when the calculated value is less than the table value, null hypothesis is accepted.
Sir, what is the table value here, sir?
That is what given in the problem 3.84.
Okay, sir.
Okay. Then next thing, what should be the null hypothesis for this problem? We have to check the usefulness of the medicine X in checking the diabetics, right? That is the question asked. What we have to start with means medicine X is not useful in checking the diabetes. That is called null hypothesis. Now, finally, what happens as the calculated value is more than the table value, we have rejected the null hypothesis, right? When you reject the null hypothesis, what happens? What is null hypothesis? It has no effect. You reject that. What will happen then? It has an effect. Okay. Do you follow this or not? Now I will tell you how to calculate this, find out the table value from the chi-square table. Just a minute.
Sir, can you repeat once more?
Which one, sir?
Whole of the problem.
First, you start with the null hypothesis. Null hypothesis for this problem is medicine X is not useful in checking diabetes. Note down this. medicine X is not useful in checking diabetes. That is null hypothesis. Okay.
Sir, but in the book it is useful, sir.
You have to find out that. For that only we have to move with null hypothesis always. Start with null hypothesis. Finally, only we can conclude whether it is useful or not. Starting, we say there is no effect. It is not useful, like that. Okay.
If hypothesis rejected means X is useful for medicine.
That is the procedure we have to test for testing this chi-square. Whenever we have to test something, you have to start with null hypothesis only. Right?
Okay.
Null hypothesis says it is not useful. Then you are proceeding with your test. Finally, you conclude that null hypothesis is rejected. You can either reject it or accept it based on the table value. Here, the table value is 3.84, whereas our calculated value is 38.593. So conclusion is, when the calculated value is greater than the table value, then null hypothesis is rejected. That is why we conclude that medicine X is useful in checking the diabetes. Suppose your calculated value is less than the table value, then you should have accepted the null hypothesis, which means it has no effect, no, not useful. So in this case, we have rejected null hypothesis because the calculated value is greater than the table value. Therefore, final conclusion is medicine X is useful in checking the diabetes. Right?
Okay.
Got it now?
Okay, sir.
Okay.
Can you explain one more problem with this example?
Wait. First, I will complete this. I will come back to that. Just a minute. I will show you how these values to be located from the table now. Just a minute, please. I will download the table and tell you. Whenever you don't get the value in the examination question paper, you can ask for the table in the examination center. This will be supplied for you so that you can make use of that. Say the degrees of freedom, first column. Is it clear now on the table, on the screen now? Is it clear?
Yes, sir.
Yes, sir. It is clear, sir.
Okay. So first column, the first column, first value is 1. That is degrees of freedom. You move to the column number 1, 2, 3, 4, 5, 6, 7. Chi-square 0.05 is there, no? After the first column, you move to second, 7 columns.
Yes, sir.
On the heading chi-square 0.05 is there.
Yes, sir.
Yes,
Yes,
sir.
sir.
That is called 95% confidence level. We have taken 95% confidence level. Usually 95% will be taken unless otherwise stated in the problem. What is the value given in that? 3.841.
841.
That is the table value for this problem. It depends upon the degrees of freedom as well as the level of confidence that you take. 0.05 means 0.05, 5% error may be expected. That is the meaning of 95%. We are confident enough. That is the meaning of this table. Suppose 2 degrees of freedom means.
So, sir, for every question,
Yeah, please.
so for every question you take this as a percentage?
Every question you have to take 95% generally, unless otherwise stated. Otherwise means 99% may be stated sometimes. In that case, 0.01 column is to be located.
Okay.
Sir,
Yes, please.
sir, in this question we have taken that chi square is 5%, sir.
Not chi-square 5%, significant level of significance is 5%.
How we can take that, sir? How we should do it?
Either 5% or 1% you have to take naturally.
Sir, can you please explain, sir? I can't understand.
That is fixed, always fixed. Either 5% or 1%.
So here
Either-
useful in
either it
medicine 95%.
95% confident.
Yes,
That means 5% error may arise. That is the meaning of
okay.
it.
Okay.
Okay. So you
Just
told
like-
about the next problem, no, in your study material. Let me move on to a study material and go for the second problem. Let me complete that also. Yes. Second illustration, in an experiment on immunization of cattle farm from tuberculosis, the following results were obtained. So this is given here. Observation is given. The observed frequency is given. In the same way, you have to calculate the expected frequency and then find out the chi-square value. Then conclusion can be made. So 4 values are given, you find out the other value, I mean expected frequency, by using the same method as we did in the previous problem. You have to find out expected frequency and make a conclusion. Here also table value is 3.84, that is given in the problem itself. That's how only in the question paper also the value will be given always. Okay?
Sir,
Yes, please tell me quick.
last 2 questions. How to find the formula of this
Which one, ma?
experiment?
When the observed frequency is given, you should know that it is chi-square test.
In textbook, okay. In examination, how will we
In the
will find out?
examination itself, I am telling, it can be done only by practice. Because even ANOVA problem may look like this also sometimes. You have to make a difference between ANOVA and chi-square test. By seeing the table value given at the end of the problem, you can easily find out. That is a shortcut.
Okay.
That is shortcut. See, this is a problem. Now, if you take illustration, second illustration, that is in page number 121, second illustration is given. No, at the end of that, what is given? You see that? Calculate chi-square. Calculate chi-square and discuss. So there itself it is given clearly chi-square. Otherwise,
Okay.
you see the table
Okay.
value. Table value is there, no? Chi-square for 1 degree of freedom. So there itself you can find out. So this is how you have to find a clue from the problem. Unless you have practiced it thoroughly. Okay?
Sir, thank you.
Okay.
Thank you.
So let me give one more problem so that you can work out and tell me the answer now. What is seen on the screen now? Is there any problem? Yes. This problem you have to work out and tell me now. Shall I read the problem now? 200 digits are chosen at random from a set.
So which page number is this question is?
Please.
In which page number is the question is?
It is not there in your book. It is separate problem. For your practice, I have given it. It's not there in your
sir.
book. So by seeing that, you can just work out straight away. I will tell you how to do this. 200 digits are chosen at random from a set of tables. The frequencies of the digits are given below. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 occurs 18 times, 1 occurs 19 times, 2, 23 times, 3, 21 times, 4, 16 times, 5, 25 times, like that it is given. Use chi-square test. So clue is given now. To assess the correctness of the hypothesis that they were distributed in equal numbers in the tables from which they were drawn. Table value is given. 9 degrees of freedom, 5% level of significance, 16.22 is given. Say, these are the observed frequencies. 18, 19, 23, 21, 16, 20, 25, 22, 20, 21, 15 are observed frequencies. Now let us move on to the solution part of it now. See, is it visible on the screen now? Solution?
Yes, sir. It is
Sir.
visible, sir.
Yes, sir.
So all the observed frequencies are written down in the first column. We have to find out the expected frequencies. Say the 200 digits are there totally, 200 digits. How many classifications are there? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So totally 10 items. So divide this 200 by 10 because it is given in the problem. They expect it to occur equally. They were distributed in equal numbers. That is what given in the problem. They were distributed in equal numbers. So 200 is distributed equally means 20, 20, 20, 20, 20 for everything. Now you can find out O minus E, O minus E whole square, and then O minus E whole square by E. You can go through from the table, from the screen. I think it is visible on the screen clearly. So finally, the total is 4.30. 4.30. Then degrees of freedom. We have only one column. C minus 1. That's all. In the column, we have 10 values. 10 minus 1, 9 degrees of freedom. At 5% level of significance, the total table value is 16.22 that is given in the problem itself. Therefore, conclusion is the calculated value, that is 4.30, is less than the table value, that is 16.22. Therefore, the hypothesis is accepted. That means the digits were distributed in equal numbers. So this is how it should be concluded. So let me give one more problem for your practice so that you can work out this, please. You can take it and work out. I suppose this is visible. Yes, this is the problem now. Quickly, you can take down this.
Sir, can you please share this video?
Yeah, I will share it. Already I have shared 2 units, I think. I can share this, no problem. After the class is over, by the end of the day, I will share it. You can make use of this. Shall I move on to the next part of it otherwise now? One more area we can cover now. What do you say? I can share this, all of you can get it and you can report.
Yes, sir.
Okay, sir.
Okay. Let me move on to the next important part of your examination. Correlation. Just, yes. Yes. Correlation is next topic, from which also you will get problems. Let me straight away go to the problem part of it. Correlation means the relationship, correlation. Correlation is called correlation. Relationship between two variables is called correlation. there is a relationship between two variables, we say that they are correlated with each other. Say, for example, you might be knowing the law of demand. No? Can you say one of you law of demand? What is law of demand? Can any one of you say what is law of demand? Anybody, please? When the
When the price increases, demand will
decreases and vice versa. Correct? Okay. When other things remaining the same, if the price increases, the quantity demanded decreases, and the price decreases, quantity demanded increases. That's the law of demand. So there is a relationship between two things. One is price on one side, other one is quantity demanded. So these two have inverse relation. When one increases, other decreases. They move in the opposite direction. On the other hand, if you take the case of law of supply, when the price increases, supply also increases. When the price decreases, supply also decreases. It is direct relationship. So when there is relationship between two variables, we measure the relationship, that is called correlation coefficients. This measurement will be useful for taking some business decisions later on. So one of the exponents, that is Carl Pearson, has devised a formula for this. I think the formula is clear now, that you can take from your study material also otherwise. I will tell you the page number, study material.
130.
Yeah, you move to 130, please. This
Page number 130.
Yeah, move to page number 130. So from that itself, I will explain this now. Go to illustration number 1, first illustration. That is advertisement expenditure and sales. So naturally, these two variables have relationship with each other. Whenever the expenditure increases, sales also goes on increases. We have to find out, we have to measure the degree of relationship. That's all. Mathematically, we have to measure it, right? So first variable, advertisement expenditure, is considered as X. Sales is taken as Y. So now that, next page. Page number 132, solution is given, X is entered here, Y is entered, then you find out the X into Y, that is one variable. Then X square of the value of X, each and every X, 18 square, 19 square, 20 square, 21 square, like that. Then next column is Y square. So square of the Y value, Y 17 square, 18 square, 19 square, like that. Find out the values of the total value of all these columns. Just you go through this so that you can know how this is being applied now. So write down the formula. R is equal to n into sigma xy minus sigma x into sigma y divided by root of n into sigma x square minus sigma x the whole square into root of n into sigma y square minus sigma y the whole square. N is equal to number of items in the problem. So in this problem, we are given 6 items. So wherever n is there, it is replaced by the value 6. Then sigma xy, 2243 minus sigma x, 109 into sigma y. Sorry, sigma x 123, sigma y 109. Then root of n, 6 into sigma x square 2539 minus sigma x the whole square. Sigma x 123 whole square. Root of 6 into sigma y square, that is 1985 minus sigma y the whole square. Sigma y is 109 the whole square. If you simplify all this, finally you will get 0.9277. What is the implication of this value? See, read out the interpretation now. I will read out this. So I will explain what is the implication of this. The correlation actually ranges from 0 to 1. When there is no correlation, you say it is 0. When there is perfect correlation between the variables, we say it 1. So 0 to plus or minus 1, plus or minus 1. It may be minus 1 also. If it is minus, we say it is negative correlation. If it is plus, you say it is positive correlation. In this case, the value is 0.9277. It is almost 1, nearest to 1. So it is a positive correlation, high level of positive correlation between these two variables. That means whenever the advertisement expenditure increases, definitely sales also will go on increase to the greatest level. That is the inference that we got from this measurement. So the value of R, that is correlation, is equal to 0.92. It shows that there is a high degree of positive correlation between the two variables, namely advertisement expenditure and sales. That means it is a basis to consider some functional relationship between them. If at all you want to increase your sales, increase your advertisement expenditure. This is the conclusion that you got from this measurement, Hall Pearson's coefficient of correlation. Do you understand this now?
Sir, will you please explain the interpretation again, sir?
The value, no? Interpretation, huh?
Yes, sir.
Yeah. The value we got is 0.92. I said that the correlation may range from 0 to plus or minus 1. 0 means no correlation. 1 means perfect correlation. If it is plus 1, perfect positive correlation. If it is minus 1, perfect negative correlation. Right? Now, in this case, we got 0.92, which means it is a positive value. Therefore, there is positive correlation between these two. Positive means they move in the same direction. If one variable increases, the other variable also increases, like the law of supply. And the value is 0.92. That is very nearer to perfect correlation 1. Therefore, we can conclude that this correlation between these two variables is high degree of correlation. Therefore, there is high positive correlation between the variables advertisement expenditure and sales, which means what is that we infer from that? If at all you want to increase the sales, you can increase your advertisement expenditure because there is a high degree of positive correlation. When advertisement expenditure increases, automatically sales also will increase. That is what we infer from this problem. That
Okay,
will be
sir.
useful for decision-making purpose for the businessman. Okay. Shall I conclude this now?
Yes, sir.
Okay. Thank you very much.
Yes,
Thank
sir.
you very much.
Sir, I have a doubt, sir.
Thank you, sir.
Please tell me.
For each sum, how many set mark they will give, sir?
Step marks will be given, don't worry, depending upon the size of the problem. How many steps are there, depending upon that, you will be getting step marks.
Okay, sir. Thank you, sir.
Definitely you will get, don't worry.
So for the steps, we can refer the solution, our study material book, right?
Yes, sir. No worry.
Sir, about these sums, how many marks you will ask, sir?
There are two parts. Either it can come in the compulsory part or in the B part. Any
Okay,
one
sir.
of the
Thank you.
problems will come in the compulsory part. Either chi-square test or ANOVA or correlation. There are so many areas are there. Any one may appear in the, say, compulsory question, and the other things will go to the B part.
Sir, where the PPT is allowed?
One please, one at a time, please.
Sir, scientific calculator is allowed for the examination.
Scientific calculators are not allowed, only ordinary calculators are allowed.
Okay. Thank you, sir.
Thank you very much for the patient.
Thank you, sir.
Meet tomorrow.
Okay, sir.
Sir, what
Sir,
if we are
next
not
class
able
you
to
can teach
understand
the
the
case
question
study, sir.
properly?
The problem the case study. The case study is problem only.
No, so for exam point of view,
Hmm.
if we are not able to understand the questions properly,
Hmm.
so will teacher around us help us to understand it?
Where in the examination hall?
Yes, sir.
No, nobody will say anything because those who are coming there have no knowledge about all these things. They are only invigilators.
Okay.
That's all. They are not the teachers. They will invigilate your examination writing only. That's all. They will not say anything. If at all they say anything, don't listen to them.
Okay, so if we just rewrite the question again and make a bracket and put a formula or something, we'll get a marks, right?
No, as long as it is relevant to the question, you will get marked to the extent. If at all whatever you write is relevant to the answer, to that extent you will get the marks definitely.
Sir, in this lessons only we will get problems which you are taught today.
Not the same problem, same type of
No,
problem.
relatively
Type of
to
problem.
this.
Yes. Sometimes same problem may also be asked.
So, and sir, please share this study material PPT or whether it would be uploaded in the portal.
I have already shared the first 2 units. Somebody has sent the email to me. To that email, I have shared it already. If at all you want, I will also share it. No problem.
Yeah, please, sir. So where can I send that email? Here
My
only?
mail.
Please share your
On the
email.
other day, I have given the mail ID. Okay, don't worry. Do take down the mail ID. Yes, Kumar.
Yes, sir.
Yes, Kumar 12459.
12459.
Yeah, at gmail.com.
Thank you, sir. Okay.
Thank you very much. Thank you very much.